Hi everyone, welcome to Dogen 1025 Forge Lukunen. This is the demo for the release. As I said on my release notes, there's a lot of stuff going on in this release. We will just have a quick look at the user-facing features, and then I'll just talk a little bit about the never-ending generation refactor and the PMM work that's been done at present. So let's just get going then. So the first feature that we put in this sprint was profiles, the fix for profiles that didn't support collection types. So that's really composed of two things, really, supporting text collections and supporting KVPs. So what we'll do is we just have a quick look at a model. What I'll do as well is, for good measure, let's just increase the size of the font a little bit to make it a bit more visible. So if we take, actually this is not a good model, text LCPP would have been better. If you take the text model, so in the past, we couldn't really add elements to the profiles that were collections. So in fact, let's just start by looking at the variability model. So in the variability model, as you can see here, there's different types of elements. Values can be of different types. They can be numbers, text, boolean, text collections, or key-value pair. We never really needed much more than these types. At one point we thought about generalizing text collection to be a collection and allow you to have numbers, text, or boolean, but in reality we never really used anything else, so we never really bothered. And these two types, text collection and key-value pair, well, as you can see here, they're collections. Underneath it there's a list, and there's a list of pairs. And up to now, profiles, such as the one I just showed you a second ago, didn't allow you to have any entries here which were collections. Now, one of the potential use cases for this was the fact that we needed to get all models, and I'll show you what I mean, to exclude tests. So this is a classic use case. We needed a collection of ignores that are common to all models. Up to this release, this was actually repeated in every single model, and it was quite painful. We had to, add this manually. As you can see, we had loads of other stuff in profiles already. All the decoration stuff, a whole lot of properties here, and it was really convenient to have all these things in profiles, and then simply just say, well, this model uses profile X, such as, for example, the default profile. So if I go here to this model, you see that this model is bound to a profile, and the profile is the default profile. Not the best of names, I guess, but you can see the default profile here in all of its glory. And not having collections meant that certain things had to be added directly to the model itself. I mean, of course, there's still a few things that can't be added to the model, such as, for example, references, but that's just to do with the way we bootstrap models. We need to read the references before we can process profiles, because the profile model is itself a reference. So as you can see here, Dogen profiles. We can't really share that, although it would be really nice to be able to have collections of references and just share them. But for the use cases that we already have, it was really useful to be able to do collections. And so what we did with this release is we fixed this annoyance. And whilst it may appear to be a very small thing, it was actually quite difficult, because what really was causing this problem was inside of the way we were merging, it required a lot of special handling for collections. So we resolved that problem now, and so it's possible to add your collections to profiles. And the biggest advantage, of course, is the new model text transforms that make heavy use of collections. So for example, you can see here all the configuration needed for the archetypes, and then we define things like the object header configuration, and then we use that, as you can see here, Dogen object header configuration, such that all the objects that have a header share the same configuration. And then you see it again here, object header configuration, and so on. And because there's quite a few of these, it really saved us a lot of time. So that was, let's just jump back to our Emacs. That was the object support collection types and profiles. The second thing we worked on, which was kind of related to the previous one, I've already showed you a little bit on the models, but you can see there, there was a lot of work happening on the moving formatters to M2T transforms. And when we did that, of course, because they are transforms, we kind of needed to ensure that they're also part of the tracing framework. And what that meant in practice was basically make sure that when we call the apply of the transform, that we started by tracing at the beginning and tracing at the end of each transform. And so what I'll do is I'll just quickly jump over to another Emacs session, which is this one here, and if we just move over to shell, perhaps we can make this shell a bit bigger. So let's just clear up this screen, and if I just go up to build output. So in fact what we'll do is before we do that, let's just enable all of the tracing in our Dogen. Should really use flags for this, but I've been a bit lazy. So we just enable all the tracing, but not the tracing for the regex filtering, and so this will produce a full tracing. So if I just go up to the Dogen by products, and now if we generate a model such as generate Dogen.cli, for example, which is a very small model, diam, it's going to go away and generate. Takes a little while now because of course we generate a lot more data. And if you go to CLI, generate Dogen.cli, a bit recursive. In this tracing directory, if I just run a tree here, as you can see, we now have a lot of information here. In particular, some of it was already there, of course. So this is the variability transforms, and in here you got the injection stuff. But as you start moving closer to the generation part of the pipeline, I'll skip scrolling, you start to see in a second, it's quite a lot of transforms, so these are all logical transforms. There you go. So now we are entering the text transforms, and as you can see here, text transforms the model to chain, and then we're going to enter the specific technical spaces that we output. So in this particular case is C++, as you can see here, and then in there now you can start to see the different meta model elements being transformed and their inputs and their outputs. And this is what's happening to every single one of them. As you can see, even for a small model we generated 81 transforms just for text model to text transforms. Now the reason why is because of course for each model element we may have several projections into the physical space, and so it quickly, well, it's not quite combinatorial, but it is fairly it's a very large expansion. So as you can see, we end up with 521 files, which is quite a fair bit. Now what we'll do is, for good measure, I'll just quickly show you what you can do with this new transform tracing. So if we look at the text transforms and the chain itself, might take a few seconds to load up the 500 files, or the 81 files should I say. So here you could use the usual JQ, and so this is now showing me the model element that was used as input to this transform, and here I can see everything about that model element exactly as it was just prior to the text transform. So you see all of its configuration, for example. You see all the artifact properties, which are going to be moved at some point, and so forth. And then, for good measure, actually I think I just outputted the wrong one. Oh no, this is the input, so that's correct. And then, for good measure, we can also output the output of the transform. Now, for the output of the transform at present, we have a sort of a text encoded into JSON. In order to make JSON compliant, of course, you need to remove all the new lines and all sorts of things. So whilst that's useful because we can see all the properties of the artifact, What we really need is a way to now call a function, probably in Emacs, that just takes this chap here and converts this to a text file, so that it looks like the thing that we're going to write to the file system. Otherwise, it's just a bit difficult to read. But nevertheless, it is really that's probably quite an easy thing to do. Really, it's just a set of regexes that we need to apply to here to replace things like new line and so on. It's probably quite an easy thing to do in Emacs. I just haven't had the time to do that yet. And so that is this feature, the tracing, and we already spoken a little bit about tracing files. So of course, as you can already seen, we generate a lot of tracing data now, and it takes a few seconds more than it used to before. If when you're generating a larger model, it takes more than a few seconds, which means that's not ideal. So if you just want to do some very specific tracing, you know exactly what you're looking for, then it doesn't make a lot of sense to dump the whole lot. So what we've done is we added this new parameter called tracing filter regex, and here it is being used as an example. And this guy here will just filter things with text transforms on it, and everything else that doesn't actually get generated. And the filtering was done in such a way that we don't pay anything unless we are actually going to write down the object. So it should really be very cheap to run. So what we'll do is we just first generate that model again, and then have a quick look at the shell. Now we can run the same three commands. In fact, we can't, but we need to cd back into the directory again. If you run the same three command, you see that there's only 5 files this time around. There's quite a few directories. We couldn't really stop the directory creation, but the files are going to basically be the initial inputs to the model, and then basically the things that filter, such as this chap here and this output, and that's pretty much it. And so with this, you can now say, well, I'm only interested in, say, a specific meta model element that I want to see the transforms, or I'm only interested in a part of the chain. And also because we named the transforms according to the containment of the model, if you want all the logical stuff, you could just basically look for logical transforms and so forth. So it should be very easy to get filtering by components via the regexes. So that's that. The handling of container names is incorrect. This is kind of related to the problems that... Oh no, actually, let's just have a quick look at what we spoke about already. No, actually, this is a new feature. So the handling of container names is incorrect. What was happening with this was because we never really had any codes that compiled for containers such as modules. We never really had a problem, or never really noticed a problem with it, what was being generated. But in reality, the code that was being generated wasn't correct. So what I'll do is, let's just jump quickly to previous Emacs, and we could very simply find one of these guys. So if I look for projects, perhaps text.cpp, I think, and what we'll do is just locate something like the transforms header file. Although perhaps no, this is only being used recently because of course we implemented that as part of the physical meta model work. So maybe logical model. I believe the logical model had transforms. Not sure how recent this file is. So what we'll do is have a quick look at the history. That seems old enough, March 16th. Okay, so if I have a quick look at how this file was before, what you can see here, prior to this change, the file was showing Dogen logical. Now as you can see here, transforms HPP, really this is the documentation for the namespace transforms, which is contained inside of Dogen logical. Types is just a folder, not actual namespace. So then there's obviously something wrong here. We should have actually put all the namespaces in which this thing is contained in. So with this fix now, as you can see to the left, it's actually generating the correct namespaces. which is what we wanted in the first place. Now the reason why we did this fix wasn't so much to fix the documentation, it was more of a consequence of what I showed already, which is in the text model we started creating containers other than modules, such as for example facets, so and backends as well. So if I open up transforms, I mean, this is a bit difficult to explain at the moment because there's a lot of hackery still going on, but really this namespace here should be called CPP rather than transforms, because that's the name of the backend. But there's still a fair amount of cleanup that needs to be done until we get to that point. But meanwhile, we are already generating the backend for C++, and the notion is that it will be whatever the namespace is plus backend chain, and that's how it gets projected from the logical space over to the physical space. And because of the containment issues, of course this was being placed in the wrong namespace, which was causing everything to fail. So with this release we fixed that, and of course as you can see here we're also generating the properties for the backend. Similarly, and this is where the problem was detected, we are also doing the same thing for facets. So this is a little bit more logical. So as you can see here, the facet types is being generated here, and this is a representation of facets in the physical domain, and it's showing us the physical meta model entry for this facet. And of course there is implementation that corresponds to this, which will be this chap here. And as you can see, it generates the facet, it picks up all the archetypes, and does the right thing there. Although we probably should be talking about this in the next story. Another very useful thing that we did this sprint is we finally had the time to play around with Stitch. Now I'll just show you an example of one of the Stitch files we've got. So in the past we had fundamental mode, I guess. Let's just do a direct jump here. I'm not entirely sure why, but direct jump seems to... Right, so if I'm in fundamental... Well, the reason why you can't see that is because when you jump from fundamental mode, from Stitch mode to fundamental mode, it still keeps the font lock. So it appears as if we had syntax highlighting in fundamental mode, which was not the case. All we used to see in fundamental mode was just a plain text file. In fact, if I just do a quick hack here, so if I just rename this to crap.txt, and so this is what we used to see really, a plain text file with no syntax highlighting. Now, because we've done this for a while, it was doable to know where you're inside of the template and where we're actually outside of the template, and you know, we kind of got the hang of it really. But if you compare that to editing it via the Stitch mode, of course it is much easier now, because now you see the highlights for the things that are inside of the template in C++, and then in text mode you see the things that are outside of the template, depending which mode you're in. And so this is extremely useful when you're editing. You still get some support from the usual Emacs modes, but not quite as good as you want really. So for example, Emacs is not clever enough to be able to pick up the parentheses because it gets confused between the different modes in the template. But nevertheless, this is really, really useful. And of course now we are looking into changing updating the modes to cope with the whale templates as well. Because if you remember, we have the whale templates in the model now as well, such as these chaps here. It would be really nice if we could take the content of the whale template, which is this guy here, and then at present, if I edit it, there's one example here. You see, we just see the text, but of course, what we really want is to see these fields here in the template quite nicely highlighted, so we know where they are. So that's something that we probably will do next sprint, or this sprint should I say, because the demo is in the Spring 26. That was that. So create archetypes for all physical elements. I've shown the physical, the text model quite a few times already. So I guess there's not a lot to see here. What we've done is we've taken a whole load of these chaps here, and there's quite a few of them. It's probably easy to see this in a smaller So as you can see, we have at present a very large number of archetypes, all of these archetypes, and of course there's also the C# ones, not as numerous, but still a few. And all of these had to be updated one at a time. It was quite a painful thing to do, as I've reflected a few times in the release notes. It also required doing all the profiling and all the modeling for the profiles and making sure we got that right. And in addition, because we're still stuck here in dia mode rather than the new shiny injector that we're working on, everything is in these models, so now we have to edit the documents from within properties and attributes and so on, which made it much more difficult than it should have been, really. But we just needed to go through it and do it because it's a step, and we don't really want to get the refactors too much in a tangle. So before we can start one refactor, we need to finish the existing one. So sometimes you just have to take the pain and finish it all. So yeah, that was one of the main achievements this sprint, really. We managed to go through all of these chaps here, update them, and now the good thing about it, of course, is that they are part of the framework. So as you can see, and as you already seen when I demonstrated the facets, you can see here that the facet is automatically picking up all the archetypes that it knows of, and it's automatically generating the physical meta model for it. In the future, of course, we will also use the generated code to run the chain. So whenever you add a new archetype, like such as these chaps here, we'll automatically get it plugged into the plumbed into the framework, should I say, and quite literally it will start generating code. So it will be really easy to create new artifacts. So that's going to be quite nice. Okay, so we've already discussed a bit the updates for the formatters, and I'll just spend a little bit talking about the PMM. So the idea with the PMM really is that we, in the past, we were generating manually all of the geometry of the physical model, and what we've done, maybe 1 or 2 sprints ago, is we've made sure that the physical model, which is this chap here, contains a proper meta model for itself. Here you have the meta model for the physical model, and that contains the entities that describe the physical meta model, such as the kernel, the backends, facets, and so on. And so what we've really been trying to do for a little while now is we've been trying to get the code generator to create an instance of this physical model that describes the current geometry of the space. That's all done via the magic of what I just showed you a second ago, which is the fact that these things know how to describe themselves. And once we've got a PMM generating itself, then many things are going to become possible, because then we'll be able to do things such as implement the locator in a way that's completely independent from the technical space we're in. Because at the moment we have these hacked locators, as you can see here, with all sorts of things such as give me a full path for a C++ header, and all these things will be data driven rather than this hackery that we got here. So it's kind of a long-term goal we've been chasing here, that refactoring, and I think we're getting really close now. I think next sprint is going to be quite exciting now that the hard work has been done. Okay, I think that's all we got for this sprint. Thanks for tuning in.